Hello everyone, this is Prakash. Welcome to another day of Deep Learning Tech to Master series. So today in this video, we'll understand one of the basic and important concept in deep learning. So that is activation function. So let's understand what is activation function. So in general term, we can say that activation function gives the power to the neural network to learn the hidden patterns. Okay, like why you used activation function? Well, without the activation function, your neural network will behave like a simple linear equation. So whatever thing you are like you have observed in the machine learning linear regression, it will consider the same as a linear equation without the activation function. So no matter how many hidden layers you have inside your neural network architecture, without the activation function, your whole entire neural network will be acting like a linear, simple linear regression without learning any of the hidden patterns or complex patterns. Okay. So with activation function, what will happen? It will introduce a non-collinearity to your neural network so that the model, the network can learn the complex patterns and hidden features. So let's understand how many activation functions are there. So basically, there are five activation functions, the most popular activation function. So one is your sigmoid, and then Tanh, then ReLU, ReLU, and subtomax. So we'll understand one by one. Sigmoid is the activation function. It helps to convert the input in the range between 0 to 1. Okay, so this is basically ideal for the binary classification problems. So I think in the statistic machine learning also we use the sigmoid activation function in terms of the classification problems. Okay, in Tanh activation function, what it will do? It will convert the output in the range of -1 to 1. So Tanh activation function is basically used in the recurrent neural network problems and LSTM. But there are couple of drawbacks or demerits, I would say, in the using in using the sigmoid and Tanh activation function. So like they're likely to have your vanishing gradient descent problem. So what do you mean by vanishing gradient descent problem? So when you are back propagating in the neural network, if you convert the input, if you use sigmoid as the activation function to convert the output in the range between 0 to 1. So like for in the early layer of your neural network, early layer means the hidden layers which are near to the input layer. Okay, so in the early layer of hidden layers, what will happen? The gradient value is near to 0, and when you are multiplying anything with a small number, again it will become very small. So your weights will stop updating. Okay, because see weight, how you are calculating the weight? Well, so your weight will be like old weight minus your learning rate into your gradient, right? So in the early layers, what will happen? Since the value is very small, near to 0, the weight will stop updating. Then the model will fail to learn the hidden patterns. That is your vanishing gradient descent problem. So in a ReLU and liquid ReLU, you'll overcome with this gradient descent problem. Why? Because with the ReLU activation function, what will happen? It will pass your input value as same. When your input value is a positive number, it will pass the number as it is, and if your value is a negative number, it will convert it to 0. Okay, so since you are passing the number as it is, or maybe uh, not a small number you are passing, hence you will less likely to have vanishing gradient descent problem in the ReLU. But there is another cons in this ReLU activation function, that is your dying neuron or dying ReLU, or maybe dead neurons problem. So what do you mean by dead neuron problem? Okay, so let's say you have multiple or higher number of negative inputs in your neural network. With the ReLU activation function, the negative value will be converted to 0, like it will pass it as 0. So that's why you will lose there is a probability to lose the important features. So with the ReLU activation function, you may likely to have the dead realms problem, but that will be overcome in the ReLU activation function. How? Liquid ReLU is same as ReLU. It will just pass in. It will just input a small number into your negative value. So if you are having negative inputs, it will multiply a small number to avoid the zero, and positive number it will pass as it is. Okay. Actually, ReLU is the default choice for your hidden layer hidden layer of the neural network. And there is another activation function like is available, that is short mask. Basically, short mask is used for the multi-class classification problem. So when a multi-class output layer, you can use short mask as activation function. It will convert the input into a probability in the range of 0 to 1. So like what is the probability? So let's say you have 5 class. Then what is the probability of each class, you know, being a output? Like in the output, what will be your probability of those class? So when to choose which activation function? Well, Sigmoid activation function basically best for binary output layer. So you will not be using Sigmoid in any of the input layer. It will be only applicable for the binary class problems of binary output layers. Okay, antennas is mostly best for RNN, which is your recurrent neural network, and LSTM. Then ReLU is the default choice for the hidden layers in the neural network. Okay, and ReLU, when the ReLU neurons die, like when you are facing dead neurons issue, then you can select ReLU as your activation function. And submask, I think we already discussed, it will be useful for the multi-class output layers. Okay, so that's all for today. Thank you.